Hello, this is video 15. I'm going to go over how to add vectors using the analytical method. In a previous video, we used a geometric method, we used a tip-to-tail method, but in this video we want to get exact numbers when we're adding our vectors. So we're going to have to make use of adding how to find vector components, which we just found in video 14. So here is how to add vectors algebraically. You can see in this picture here that there's the tip-to-tail method being used to add vectors a and b. We have vector a over here, at the tip of vector a we have vector b, and then the resultant is shown from the tail of a to the tip of b. This is what we talked about in the other video on adding vectors geometrically. So the reason I still have this picture here is because it really helps to explain these steps here. You can see what is shown for vector a here are the two components, the horizontal ax and the vertical ay. And the x and y components of vector b are also shown. So that's what you have to find in step 1. In step 2, you have to add the x components, ax and bx. You can see in this picture that when you add ax and bx, right, if you were to put bx here at the tip of vector a, x, because you can move vectors around as you want without changing them, you can see that ax plus bx is equal to rx. And then you can see the same thing with ay plus by. If you add them tip to tail, you get ry. So you do that separately for the x and y directions, steps 2 and 3. And then once you have rx and ry, which are the x and y components of the resultant, then you can use a Pythagorean theorem to find a resultant. You can see that rx and ry form the legs of the right triangle and r is the hypotenuse. And then you're going to use the arctan to find the angle. And we'll talk about this in depth in the two examples that I'm going to go over in this video. The first example is the same one that we saw earlier that we did using the tip-to-tail method, but this time we're going to do it using the algebraic method. So the first thing we want to do is we want to label each vector, and I'll just draw a quick sketch, not to scale, of what we did last time. This is vector A, 45 paces east, and then this is vector B here. Again, this is not to scale, and this is vector C here, just so we can see what we're doing. And then the resultant was from the tail of A to the tip of C. That was the resultant. But what we want to do is separate the x and y directions. I like to physically draw a line on my paper, and then I want to show that I'm finding the x component of each vector and the y component of each vector. So I like to write them all down, and then I go ahead and figure them out. So let's look at vector A here, where we're going east. That's only in the x direction, so that's 45. When something's going left or right, no part of it is going up or down. It does not have a y component, so that's 0. And for B, this is our angle 30 right here. So the x component is going to be the side adjacent. So we learned that when we're finding the adjacent side that we use cosine. And bx, if we draw B on the side here, bx will go to the left. So make sure to put a negative. So negative b, and b is 60 here, negative 60 cosine of 30. Plug this in the calculator, you get about negative 52. I'm rounding here, but I don't round in my calculator. I'm using the exact number. And then cx, well, c was going north. Something's going north. It's not going east or west, so cx is 0. Then by, well, the y component here is the opposite, and it's going up, so it's positive. So 60 sine, you always use sine for the opposite, and that's equal to 30. And then cy is going to be 25. So those were steps 2 and 3. The next thing that we have to do is we have to go ahead and add all of these components here. When we add ax, bx, and cx, we get rx. And I think this is actually steps 2 and 3 in my previous slide here. So when we add all of these, we get negative 6.96 in the x direction. When we add 30 and 25, we get a y component of 55. And then step number 4 said now we can find r. And before I do this, I always like to draw my rx and my ry vectors on the side just to have an idea. Maybe I didn't draw this original sketch. And let me just draw rx and ry, not to scale, but just to know which way it's going. Rx is negative, it's going to the left, and I draw it tip to tail with ry. Ry is positive, going up. I like to draw this triangle because it shows me exactly which way r is going. If rx is going to the left and ry is going up, then r must be going northwest. So we can use the Pythagorean theorem to find r. Use the square roots of rx squared plus ry squared. So when we plug in these numbers, we end up with 55.4. And the units here is going to be paces. And then the direction, I said in the previous slide, step 5, that you're going to use the inverse tangent of the y over the x. Now, what I like to do is when I plug this in my calculator, again, make sure that you're in degree mode, I like to just plug in positive values for ry and rx. And this will give me an angle of 82.8 degrees. I'm just using positive numbers, but then I can look at my sketch to specify exactly which way is this going. Well, the angle I just found is theta is right here. The reason I know I just found this theta is because the opposite is ry and the adjacent is rx, and that's the definition of tangent, opposite over adjacent. So by drawing the sketch and using positive numbers in here, I can just look at my angle and say, okay, well, this angle is going to be north of west. And I always recommend doing it this way so that you don't get confused. Take a minute to draw it so you know exactly which way that vector is going. Let's do one final example. And it's very similar, just to give you a little bit more practice. So this one already has a sketch. We're going to follow the exact same steps as the previous one. And the first thing is to go ahead and separate the x and the y directions. And then there are 3 vectors, so I like to go ahead and write down the x components for each vector, ax, bx, and cx. And then I like to write down the y components, ay, by, and cy. And then I like to fill in the blanks. So vector A here, the x component would be to the right, and the y component would be upward. So the x component would use cosine because it's adjacent, so 180 cosine of 30, and that's going to be about 156. And then the y component has to use sine. Since we've already used cosine, the y component is opposite. So 180 sine of 30, which is going to be 90. For the b, really pay attention to the angle that you're given here. The y component is upward and the x component is to the left here. But you see that the x component is opposite of this angle. So that means it's going to use sine. So it's going to be, and it's also pointing to the left, so it's going to be negative. Negative 160 sine of 20. And this is equal to about negative 55. Again, I'm rounding on the paper here just because of room, but I'm not rounding in my calculator. I'm using the exact numbers until the very end. And then the y component is going to use cosine. So 160 cosine of 20 degrees. And that's going to give me 150. Just had to find the right number there. And then cx, c is all to the left, that's all in the x direction. So cx is negative 190. cy, there is none because it's all going to the left. Nothing is going up or down, so that's 0. And then the next step is to go ahead and add up all the x components to get rx. When I add up all of these numbers, I get negative 88.8. When I add up all the y components, I get 240.4 if you'd like. And then I like to take a second and draw these two. So x is to the left and y is upward. This shows me exactly which way my resultant is going. Now, I already know which way the resultant is going because there was a sketch given, but you can see that this resultant here does have a component to the left and a component upward, which is what we just found. So now we are ready to use the Pythagorean theorem to find the magnitude of the resultant, rx squared plus ry squared here. And I got 256. And I'll put my units in, which are meters. And then the angle that we're going to find is going to be this one. When you use the inverse tan of the y over the x, then the angle that you find is always going to be the one that's touching the horizontal axis. That's a little trick for you. So when I plug this in, I'm going to get 69.7 degrees. Again, I only put in positive numbers in here. And now I can say, okay, based on my sketch here, this is, just like the previous example, going to be north of west. So that concludes this video. I hope that you understand how to add vectors algebraically. Really, the best recap of this video is just to look at the steps that we have right here, that you have to go ahead and find the x and y components of each vector. I like to write them down on the paper, separate them with the vertical line. Then you add up all those x components that are in that left column. You add up all those y components that are in that right column. Then use a Pythagorean theorem to find that resultant. And then also you can find a direction using the inverse tangents.